All right, welcome back. Part 2 of 6.2 on radicals and rational exponents. This one's going to all be about rational exponents, which rational here, we can kind of think of that as another word for fraction. Calling this part 2 of 6.2, we covered radicals. Now we're going to do some rational exponent stuff today and relate that to our square roots or radical stuff that we learned last time. So stay tuned and here we go. All right, so a little bit of a review here. Last time we learned that for like square root of 25, we can say 25 is 5 times 5. Since my index is squared or 2, I'm looking for 2 5s, so the square root of 25 would be 5. Similarly, I could say that if I want to do a cube root of 27, 27 would be 9 times 3, and 9 is 3 times 3. So I'd have 3 3s here, right? Cube root of 3 times 3 times 3. So the cube root of 27 would be 3. Now, we're going to kind of write this in a different way starting today. And so 25, instead of saying square root, my kind of invisible index on 25 is 2, right? I kind of have that invisible 2 there, meaning I need 2 5s. The way I'm going to write that today is 25 to the power of 1/2. And 25 to the power of 1/2 means exactly the same thing as square root of 25. They mean the exact same thing. So if I'm looking to find the square root of 25 or 25 to the 1/2, it would be 5 in the same way that square root of 25 is 1/2, which I already covered up here, right? And so it's just a different notation. I can write to the power of a fraction 1/2, and that means the same thing as square root of 25. Similarly, for this one, cube root of 27, another way of writing that is 27 to the 1/3. And so 27 to the 1/3 ends up being the same thing as cube root of 27, which I can then write as just 3, right? Same thing as I had up here. I just have this new format. Instead of writing it as a square root, I can write it as a fraction exponent. So square roots are the same thing as fraction exponents. Let's try 2 of those. All right, first one we're going to look at 64 to the 1/2 and 64 to the 1/2. I'm going to do this one for you. I can kind of rewrite that as square root of 64. Square root of 64, 8 times 8 is 64, so square root of 64 would make 8. I'm just rewriting that fraction exponent in a problem with a square root in it because I'm more comfortable looking at it that way. All right, you go ahead and try one now, 36 to the power of 1/2. Again, we can re-express that as a square root. Go ahead and try that and enter your answer when you're ready. So the square root of 36 is 6. Hopefully you entered that one as your answer. Let's try another one here, 125 to the power of 1/3. Again, 1/3 is going to indicate cube root. So go ahead and make that conversion into a cube root problem and enter your answer when you're ready. So we got cube root of 125, and again, 125 is 25 times 5, and 25 is 5 times 5. So that's 3 5s, so 5 times 5 times 5, 125. So the cube root of 125 is 5. And again, another way of writing the cube root of 125 would be to express it as 125 to the power of 1/3 using that fractional exponent. All right, let's take a look here at the law of rational exponents. Again, I have it written down here. It's in your textbook. What that law says is if we have x to the power of a over b, that's equal to the bth root. So whatever that lower part or denominator of the fraction is becomes the index on the square root. So the lower part of the fraction becomes the index on the square root. The numerator of the fraction becomes what you're going to raise that result to. Once you take the root, you're going to raise that result to the exponent, whatever a is. Now, in the previous problems, we always had a 1 in the top, so 1 was a on our last screen. But in general, those problems might have one extra step if a is a number other than 1. And we'll kind of see that in the next couple examples here. So kind of what this means in terms of numbers, and my example of this here is if we have 27 to the power of 2/3, that 3 is my denominator of the fraction, so I can put that on the shoulder as the index of the root. And then 2, that's my exponent, so I can raise that to the power of 2. And I'm going to start by breaking down my cube root of 27. 27 breaks into 9 and 3, and 9 is 3 times 3, so I have 3 3's here. Again, that's one we've done a whole bunch of times. The cube root of 27 makes 3. And then 3 to the power of 2 is 3 times 3, that makes 9. So for my example here for the law of rational exponents, the 27 to the power of 2/3 would make 9. All right, I kind of left our rule here up in the top. X to the a over b is equal to the bth root of x to the a. But I want you to kind of try two of these here. The first one I want you to try is 16 to the power of 3 over 2. And the second one that I want you to try is going to be 8 to the power of 4 over 3. All right? So go ahead and try those. I want you to start with number 1. So go ahead and try number 1, 16 to the power of 3 over 2. Again, you're going to convert the notation into square root form. And then once you have it in square root form, you're going to calculate out the root and then raise it to the exponent and then enter your answer when you're ready. So reorganizing that, I have square root of 16 to the power of 3, right? My lower part, my denominator, is 2, so it goes on the index. My upper part, the numerator, is going to go in the exponent. My square root of 16 is 4. And 4 to the power of 3, 4 times 4 times 4 is 64. So 16 to the power of 3 over 2 is going to make 64. Go ahead and try number 2, 8 to the power of 4/3. Again, you're going to convert it to square root form first, calculate out the square root, raise it to the exponent, and then enter your answer when you're ready. All right, let's take a look at this one. I can rewrite it with my 4 in the exponent, 3 on the root. I'm looking for the third root of 8, which 8 is 4 times 2, and then 4 is 2 times 2. So 3 2's is going to make 8. So then it would have 2 to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2 times 2, which would be 4. Times 2 is 8. Times 2 is 16. So then 8 to the power of 4/3 would make 16. The last question we need to cover about square roots is whether the inside can be negative. And what I mean by that is, can I take the square root of a negative number? For instance, can I take the square root of negative 64? Now, your instinct might be to say negative 8. But the problem is that negative 8 times negative 8 is going to make a positive 64. And 8 times 8 is also going to make a positive 64. So neither of those end up working, right? So I can never have a number times itself to make a negative. And that's because if I'm multiplying two numbers together, in order to make it a negative number, I'd have to have a positive multiplied by a negative to make a negative, meaning these two numbers would automatically have to be different numbers. So if I'm dealing with a square root, I can't do it. The thing is, if I have a third root, I can. And the reason why is if I have the third root of negative 64, now all of a sudden I'm multiplying three numbers together to make a negative. And a negative times a negative makes a positive, and a positive times a negative is going to make a negative. So if I multiply three numbers together, it will make a negative if all those numbers are negative. In this case, when I go to look at 64, if I break it down with a tree, 64 I can write as 16 times 4, and 16 is 4 times 4. So that means 4 times 4 times 4 is going to make 64. And if I make it a negative 4 times negative 4 times negative 4, that's going to make a negative 64. So I found a number that times itself 3 times makes negative 64. So for the cube root of negative 64, I can find a cube root. So the trick is for even indexes, like 2, 4, 6, 8, any number, and again, when I'm saying the number index, I'm talking about this number. And again, for a square root, I don't see it, but it's like an invisible 2 there. If that number is even, I won't be able to do it. And this is why I can't have an even number of negatives to make a negative. But for an odd number, I can, right? So if that index is odd, I could calculate out a square root or a root, a cube root, fifth root, seventh root, where that inside is negative. So last one for you to try, cube root. So I guess we have to think about whether it's possible or not to find the cube root of negative 125. Think about whether that's possible. If it is, enter your answer. If it's not possible, say it's not possible. Hint, it's possible. So looking at my tree, 3 5s multiplied together is going to make 125. And if I make them all negative, 3 negatives multiplied together, the negative and negative makes a positive times the negative is going to make a negative 125. So I know that negative 5 is going to work as my answer on this one. Also, I'm realizing I made an error here. I should have written, that's not negative 64, that should be negative 4. Hopefully you got that written down right. 3 negative 4s, right? All these 3 negative 4s multiplied together made the negative 64. And the negative 64 is coming from the original problem.